Welcome to Study Loop.
This is chapter 10, Dynamics of Rotational Motion. So we are given a hollow sphere which is moving upward, incline the plane or up the hill. So the diameter of this hollow sphere is 22.6 centimeter, which is equal. So radius is our 11.3 centimeter, which is equal to 0.113 meter. The mass of this hollow sphere is 426 kg, which is equals to 0.426 kilogram. This hollow sphere moves upward and reaches height 5 meter from the ground. So we need to find out acceleration. We need to find out the angular velocity and rotational kinetic energy. So at the beginning, it has rotational kinetic energy. So this is the ball and it is moving upward. So at the beginning, we gave the rotational kinetic energy and moves and up and goes up till 5 meter height. So at this point, let's say this is point A and this is point B. At initially, the potential energy at A is equals to 0 because height is 0, and kinetic energy is, let's say we have Ka. And at point B, UB is equals to mgh, and kinetic energy at B is 0 because it reaches to here and there is no velocity at this point, and it is also not moving. So just stop down and rest. So the moment of inertia of the hollow sphere is 2 by 3 mr square. We will use the conservation of energy. So we will use the conservation of energy formula here using this information. And this hollow sphere is rotating without slipping. And without slipping, we have without slipping condition is v equals to r omega. So the linear velocity has relation with the angular velocity. So we have U equals to mgh, which is the gravitational potential energy, and k rotational, which is the rotational kinetic energy, which is half I omega square, and translational kinetic energy is equals to half mv square. Now coming to the Ka, we have half mv square, which is the translational kinetic energy, plus half rotational kinetic energy, which should be equals to, so we have k plus ua should be equals to ub plus kb, so therefore k should be equals to ub. So we have half mv square, so these are small m, you can take small m here, so it doesn't matter. So these are small m, half mv square plus half I, put the value of the I, which is 2 by 3 mr square times omega square equals to mgh. So 2 goes away. Now putting the value of v equals to r omega. So we have equation equals to half m v plus 1 by 3 m omega square r square equals to mgh. So goes away. Now putting the value of v, which is equals to r omega. So we have 1 by 2 r omega square plus 1 by 3 omega square r square equals to m equals to gh. So this gives us r omega equals to 6 gh over 5 under root. So which is equals to v. So we have v equal to under root of 6 into 9.8 times 5 meter over 5, so which gives us 7.67 meter per second. Now finding out the omega, so we have omega equals to V over R. So we have 7.67 over R, which is 0.113 meter. So we have 0.113, which is equals to 67.9 radian per second. So that's your A part. We are done with finding the angular velocity and the linear velocity. Now we need to find out the rotational kinetic energy when the sphere was at this position. So at this position, at the point A, the kinetic rotational kinetic energy is this way, which is half I omega square. So we have rotational kinetic energy at point A, which is half I omega square, which is half I is our 2 by 3 mr square. So we have 2 by 3 mr square omega square. So we have 1 by 3 m r square omega square, which is half m v square. So put in the value of the mass, which is 0.426 kg, this value, times v. We find the v, which is 7.67 square. So this is 7.67 whole square. So this comes out to be 8.35 joule. So at the base, we have rotational kinetic energy equals to 8.35 joule. So that's your answer for this question. Thank you for watching the video.